going to talk about the area of circles and sectors. We want you to learn to find the areas of circles, sectors, and segments of circles. And those last two things we know you don't know, so we'll talk about them here in the video. Okay, this next theorem we're going to talk about is Theorem 7-15. You've known this one for probably ever since you can remember doing math. The area of a circle is the product of pi and the square of the length of the radius. So pi r squared. So if our radius is right there, then we square it and multiply it by pi. And the nice thing to note is that we leave our answers in terms of pi. Leave answers in terms of pi. So if my radius equals 5 centimeters, my area is going to equal 25 pi centimeters squared. Okay, if that makes sense to everybody. I square the radius, tack a pi on, put the correct units as squared. Okay, hopefully that makes sense to everybody. So here's an example. How much more area does a 50-inch diameter rug cover than a 25-inch diameter rug? So I've got a 50-inch diameter rug, which means my radius for this is 25 inches. And I've got a 25-inch diameter rug, which means my radius is 12.5 inches. So the area that is covered by the 50-inch diameter rug, we'll call it A sub L for A of the larger, is going to be 25 squared times pi inches squared, right? And the area of the smaller one is going to be 12.5 squared times pi inches squared. Now, at this point in time, we need to get out a calculator. So the area of my larger one is 625 pi inches squared, and the area of my smaller is 156.25 pi inches squared. Since both of these are in terms of pi, I can just subtract the two. So 625 minus 156.25, and the bigger rug covers 468.75 pi inches squared more area. Okay, so that's a huge percentage. Let's see if I was just saying the percentage, that so 468 divided by 625. So the little rug only covers about 25% of the area that the big rug covers, even though the diameter is only half as much. Just kind of saying that's how funny how area works like that. Let's talk about sectors now. Sectors. The definition of a sector is the region of a circle that's bounded by the arc of the circle and the two radii to the arc's endpoints. Okay, so it's a pi piece. So if you think of a sector is a pi piece, and it's named like an angle, with the center of the circle being like the angle's vertex. So this is circle B, and we have A, B, C. Then my sector is called sector ABC. Okay? So that's a sector is a pi piece. And what we want to think about with this is how much of that total circle that sector is. So Theorem 7-16 says the area of a sector of a circle is the product of the ratio of the measure of the arc, which is how many degrees it goes around that circle, and 360, and the area of the circle. And if we look at this, we're talking about this ratio here. So the measure of my arc divided by 360 degrees, that's degrees up here and degrees down here, which gives us a ratio. And this ratio allows us to really calculate the percentage of that circle that is being taken up by that arc, okay? So once we calculate the percentage of the arc that the sector makes, then we can multiply that by the total area of the circle, and we get the area of the sector, okay? So we figure out the percentage of the circle and multiply it by the total area of the circle, and then we get the area of the sector. So let's take a look at what that looks like. So we have a 60-degree arc, right, with a circle with a radius of 5 centimeters. So first, if I want to find the area of my arc, I'm going to have to find out how much of my 360 degrees is 60 degrees. And I'm going to multiply that by 5 centimeters squared times pi. So 60 divided by 360 is 0.167, repeating, times our 25, which gives us 4.16, repeating, pi centimeters cubed. So if we wanted to approximate that, that is going to be about 4.2 pi centimeters squared, okay? So that is the area of a 60-degree arc in a circle with a radius of 5 centimeters. Now let's talk about segments, okay? We have a, here, let's see if I can make this a little less opaque. If we are talking about, I'll do a wide pen stroke here. We're talking about a segment. First we have to define a sector that's associated with it. So, and that's our pi piece right here, right? So we have this pi piece. And if we subtract out this part right here, then what we're left with is our segment. So our segment is just this little sliver thing here. So a sector minus a triangle minus triangle equals a segment. So think of a segment, it's like the crust of your pie, okay? If we want to find out how much area is in the crust of this pie piece, that's going to be our segment. So it's going to involve a little bit of subtraction type stuff here. So let's calculate the area of a segment. So we want to find the area of a segment, not sector. Wow, I was really not doing well when I made this video. Bounded by a 120-degree arc in a circle with a radius of 10 centimeters. Okay? So, how we do this is we first find the area of the sector. So the area of the sector is going to be 120 degrees over 360 times 10 centimeters squared times pi. And that's the area of my sector. So that is 100 thirds pi centimeters squared. That's the area of my sector. Now I need to find the area of my triangle. And that's going to be 1/2 base times height. Well, if I know my base is 10, I need to find my height. Right? And I know this is going to be 10, right? So we have to think in terms of angles here. If this is a straight angle and 120 degrees is related to this angle, then this angle in here is going to be 60 degrees which makes this one 30 degrees. Now I get to use my special triangles. And I know my short side is half my hypotenuse, right? So that's going to be 5. And the height then is going to be 5 square root of 3. So my area of the triangle is going to be 1/2 my base, which is 10 centimeters, times my height, which is 5 radical 3 centimeters. Okay? So that is going to be 25 radical 3 centimeters. Now I need to subtract these two things. So my area of my sector, or segment, I keep saying the wrong thing, is going to equal 100 pi minus 25 radical 3 centimeters squared. So, taking out our handy dandy little calculator, we will approximate this. So what we get is approximately 61.4 centimeters squared. Okay? So we kind of have to do the approximation because we can't really... this number makes no sense otherwise. You have no sense of what it is. You know it's about 100 and this is about 50, but you know you need a better sense of it. And so we use the approximation when we have stuff that's in terms of pi and stuff that's not in terms of pi, and we really need to make sense of that. So that's when you cease keeping things in terms of pi. Hopefully this makes a bunch of sense to you. There's more examples in the book, especially for area of a segment, but don't forget to use your special triangles whenever possible. We're not going to give you anything too radically crazy because you haven't had trigonometry yet, so you can rest a little bit easy on that. Know that we've learned how to find the area of a circle. We've learned what a sector is, that's our pi piece, and how to find that area with the percentage of the circle that is in the pi piece times the area of a circle. And we've learned what a segment is. That's the crust of our pi piece, and how to find its area. We take the area of our sector, and we subtract the area of the pie that you ate, and then we find out what the area of that crust is, or the segment is. So hopefully that makes sense to you, and you'll probably forever remember the pie crust. See you guys later.